Hello friends, today in this session we are going to discuss regarding the flood frequency analysis. So in this also today we will try to see how the formulation can be used to calculate this flood frequency analysis. Various methods are there where we can find out uh, various flood occurrences. So hydrologic processes such as floods extremely or can say exceedingly complex natural events. Okay, they are a resultant of number of component parameters and are therefore very difficult to model analytically. For example, the floods in catchment depend upon the characteristics of the catchment, rainfall, then other conditions. Each one of these factor in turn depends upon uh, host of I can say the constituent parameters, right? This makes the estimation of the flood peak a very complex problem leading to many different approaches. The empirical formulae that and the unit hydrograph methods earlier that we have seen are some of the such problems, right? Now, the next approach to predict the flood flows is applicable to other hydrologic processes such as rainfall and is a statistical method of frequency analysis, right? Now, here in this session also we are going to study the various formulation as told the values of the annual maximum flood from a given catchment area for a large number of successive years constitute a hydrologic data series called as a annual series. So for this you must have the data, remember this thing, and the data are then such arranged in a decreasing order of a magnitude and the probability p of each event being you can say equaled or exceeded in the plotting position. It is called as a various formula position formula. Okay, so that we are going to see. So the flood frequency analysis is very important to understand. Now what is frequency before going to further part? The frequency is a number of time that a given magnitude uh, flood may occur in a given period. Okay, knowledge of the magnitude and probable frequency of a recurrence of a flood is necessary for first one is the economical and safe design of bridges, dams, levees, culverts, sewage disposal plants and other structures which are located on the bank of rivers and streams, right? Now, why it is necessary for the effective management of floodplains and flood defense scheme, right? To predict the possible flood magnitude over a certain time period, that is necessary to estimate the frequency with which the floods of a certain magnitude may occur, and what is important, knowledge of flood frequency is necessary. Also, the flood insurance and flood zoning, right? Either over-design or under-design of structures involves excessive costs on a long-time basis. The initial cost of bridge that is designed to pass only for a 5-year flood may be small, but cost of rebuilding is at an average 5-year interval would be large. A bridge at the same site, which is built to pass a 100-year flood, might be extremely costly. Intermediate design would provide a bridge at the site lowest average annual cost. So whenever you are going for the construction of any civil engineering structure, we'll have to see the past data, okay, so that that structure will be remain intact for a longer period. So for a flood frequency analysis, use past flood data, right? the discharge record of past data collected geological survey and other federal states agencies. Flood frequency analysis uses historical records of peak flows to produce guidance about expected behavior of future flooding, determination of a design flood. Now there are two methods of collecting flood peak data: annual flood peak series and partial duration series. Annual flood is defined as the highest momentary peak discharge in a water year, and the use of only one flood in each year is the most frequent objection to the use of annual floods. Okay, here you can see this annual peak flow information is there plotted against a number of years and the flow. Okay, such graphs are also useful. Then for evaluation of a flood frequency can be classified into two approaches. One is the statistical approach, estimates the flood quantities by applying the probability models, and the design storm methods uses this rainfall runoff model. Okay, so we are dealing with here the statistical methods. There are many methods in that. In the first one is the probability plotting method, Weibull formula, Hazen method, California method, and Gumbel's method. But mostly this probability model, Weibull formula, Gumbel's method, these are more popular in the calculation. Now in the flood frequency analysis, it is necessary to understand what is return period. In the return period, it is also called as a recurrence interval, sometimes repeat interval, is an estimate of the likelihood of flood or a river discharge flow to occur. Okay, so very important to understand this. What is the return period, right? For example, a 10-year flood has a 1 divided by 10, that is 0.1 or 10% chance of being exceeded in any 1 year. Okay, this does not mean that if a flood with such a return period occurs, then next will occur in about 10 years time. Instead, it means that in any given year there is a 10% chance that it will happen, regardless of when the last similar event was, right? So this is a very simple case that for a 10 years flood, that 10% chance of being exceeded in any area. So that is a better understanding of a return period. Okay, then return period, it is a statistical measurement typically based on historic data and usually used for risk analysis to decide whether a project should be allowed to go forward in a zone of a certain risk, or to design structures to withstand an event with a certain return period. Okay, so today just we will discuss the three methods, right, along with this particular statistical methods. One is the Weibull method, Gumbel method, and Pearson method. Now first we will discuss regarding the Weibull method. Now this Weibull method in the probability theory and the statistics, it is a continuous probability distribution. It is most commonly used method. If n values are distributed uniformly between 0 and 100% probability, then there must be n plus 1 intervals, n minus 1 between the data points and 2 at the ends. Okay, so how that we'll see afterwards, but let's have the glance on the formulation. The probability P is equal to m divided by n plus 1. Okay, this can be, the many books they are using this m and as a capital as well. Okay, where this m is mentioned as a rank, but this is nothing but the order number of the event. Okay, m is the order number of the event, or it is called the rank. Then n is the total number of events in the data, right? And this this will particular, we can calculate from this particular, from the probability we can calculate the recurrence interval, that is t, you can calculate t, which is given as a 1 divided by p, right? So here example is given, what data can be used for this. You can see for the data here it is given for the, so we are not going in detail because as we have decided that the numerical examples will continuously will have in a sequence of lectures, and so that because all are interlinked, so once we start with the numerical methods, right, so these are interlinked, and that it is better for the understanding, because in the every unit is plotted in a, you can say it is given in a discrete manner. So if you are linking with that, so numerical examples, just I am today in this lecture also giving the examples how the data is used, how the problem can be solved, only how the formulation, this will take a long time. So one problem or two problems in every lecture that will cover in the coming lectures. So year wise the data is given of a discharge, okay, whatever the unit is there. So for example 1950 804 is given, so likewise in 1994 it is 348. So annual maximum discharge of the river is for 45 years is given here, okay. So what is important, you must have the data. Then it is plotted in how this is to plot, that we will see. It is plotted in the time series on you can see on this x-axis the year is there, on the discharge is plotted on the vertical, okay, and this is from the data it is plotted. The data is arranged in descending order. The rank is assigned to the arranged data. So these are the important requisites of this statistical method or Weibull method. So data is arranged in the descending order. Please remember all these things. Rank is assigned to the arranged data. The probability is obtained by using this formulation, that where the p is equal to m divided by n plus 1, where this x is greater than equal to xm. So what we will see this return period is calculated, the maximum annual discharge versus the return period is plotted. Okay, you can see by using the formulation how the formulation can be made, okay. So for that what is done, the rank is given, right, this is data is arranged, okay, arranged data is there. So you can see from the higher to the lower data it is arranged, okay. This is, you can see here annual maximum discharge is there, then p is calculated and the return period is calculated by using the formulation, okay. So one by one we'll see that those example. At present we'll just see what is the methodology which is used in the flood frequency analysis, right. Then you can plot this particular plot or graph, you can say. So return period on this axis, okay, generally a semi-log paper is used for this, and annual maximum discharge is plotted on the y-axis as a cube, right. Then also you can see the further it is explained, you can see this particular data how it was arranged. It is arranged in the descending order, right. So maximum, you can say this particular value will be plotted at the top one, and so here by using this equation, this probability is worked out, okay, for every year. So by using this particular equation, p is equal to m divided by n plus 1, okay, and the return period for every particular year it is worked out, okay. So very simple method. So in the same way the other methods are there. Then this plot is again say return period, and the rainfall in millimeter has been shown, and it is a logarithmic curve is there, okay, log curve is there. So rainfall frequency analysis by using the Weibull method can be plotted on a semi-log paper. So please remember this. Then one more method is there, Gumbel's method, which is also called as a Gumbel's extreme value distribution method. Scientist E.J. Gumbel in 1941 was considered that annual flood peaks are extreme values of floods in each of the annual series of recorded data. Hence, flood follow the extreme value distribution. So, two equations are associated with that in the same way. Only this equation was changed where probability P is equal to 1 minus e raised to minus e raised to minus y. Okay. So, and return period, as we have seen, that T is equal to 1 divided by P. Okay, so this is the probability, the 1 divided by P. So where y is equal to reduce variate, and this is given by this formulation. Okay, so we are, for example, here it is mentioned with this 1.282 into q minus q. Okay, actually that should be q bar minus q divided by sigma. This should be q bar divided by sigma plus 0.577. It is the empirical one, and E is the base of Napierian logarithm. So that we'll see. Sometimes this instead of some books are using their values as a, instead of q they are using x. Please remember this. Okay. Now in the Gumbel's extreme value distribution method. Now remember this was especially given as a for the Gumbel's distribution or a value distribution, and it is one of the most widely used method in the probability distribution functions for extreme values in hydrological and meteorological studies for prediction of the peak flows. Okay, then also in that we have to study regarding the maximum rainfalls, maximum wind speed, etc. That also. Now Gumbel defined, as stated here, defined as a that flood for a largest of a 365 daily flows and annual you can say a series of flood flows constitute a series of largest values of flows. Now according to this particular theory, or you can say this particular practice of extreme events, the probability of occurrence of an event, okay, so that will be larger than the you can say the value which is given earlier, that x and x not there, right? So here this formulation how that can be used, that is very important. In the same way, the same process is there. So also you can see here the flood, or you can say the flood magnitude for a return given period is calculated by qt is equal to q bar plus kt sigma, or some books are using there as a xt, where x bar plus kt in the sigma ways. Only just we are changing here, and this formulation of this calculating of this kt, okay, so which is a the value of value commonly called as a reduced variate. Okay, so that is calculated by using this formulation, and where this t is return period, q or x is nothing but the mean of that, and sigma is the standard deviation. Okay, so very simple one, but when you are actually solving, that will be more in the sequence. So it is plotted in the format in the same way that in the year, then rainfall is plotted. Now here, instead of the plotting the in the you can say decreasing manner, the reduced variate is calculated and it is plotted here. Reduced variate and probability is plotted, and by using this you can say the equation, the probability is calculated here, and the return period is calculated here as a 1 divided by p. Okay, only change is there, that instead of the plotting the in the sequencing here, the reduced variate y, that is worked out and it is plotted in this column. Now again, by using the data achieved, we can plot the curve against the return period and the rainfall, so that you can understand the nature of the this particular extreme value distribution. Okay. Then next one is a log Pearson type 3 distribution method. Now this Pearson, this particular method is generally, this particular distribution is extensively used in the USA. okay, for the projects sponsored by the US government. And in this the variate in the first transferred into the logarithmic form to the base 10, right? And transfer data is then analyzed, and if the value of that q or x is the variate of the random hydrologic series, then the variates are calculated. Okay, so here also, so these values are, you can say the formulation is given. So as it is in 1930, Pearson, he developed this theory, and in this method it is recommended to convert the data series into logarithms by using the various formulation. Compute the logarithm of the flow of log of q bar, estimate the average of log q or x, that please remember that. Now here the statistical total statistic is there. Compute the standard deviation sigma log q, compute the skew coefficient. Okay, this formulation we'll see it afterwards. By using this particular formulation, calculate the skew coefficient, and what is the skew coefficient and this thing, that we'll see. Then qt or that xt is calculated by again using the log k, where the k is the log Pearson frequency factor based upon the CS and the return period. Okay, so again here what is changed now in the table? Earlier in the same way that rainfall is plotted, but now here the log rainfall is plotted by whatever the formula is there. So that log rainfall is plotted, okay, here, and by which so you can see, by which you can plot the graph again in the similar way by using the rainfall and the log rainfall. Okay, and how the flood frequency is calculated by using the Pearson method, so that we will see when the numerical examples on. But remember, so in this unit 3, all the theoretical part, or you can say today we have seen the numericals also, how it is calculated, but actually how to calculate when you are using the statistical method, that is very important. So from next time we will start with the unit number 4, but please go through all the part that we have covered. So thank you very much joining this section.